Next up, problem 14, let triangle ABC, I'm gonna try and pick it up a little bit. Let triangle ABC with AB equals AC and BC equals 14 be inscribed in a circle omega. Let D be the point on ray BC such that CD equals 6. Let the intersection of AD and omega be E. Given that AE equals 7, find AC squared. So start off with a diagram. The way that I always do my diagrams is I draw a circle. And then usually I do it on lined paper. I draw like along the lined paper. I'm just going to demonstrate this. Pretty sure I can't turn on lined paper. Yeah, the way I always do it is I draw a circle when this is on paper, and like in order to draw a circle using a compass, you have the center one and you just go straight up. And it's easy to choose the topmost point. You can kind of tell, and then you choose one of these lines, and voila, you have an isosceles triangle. Okay. And I'll finish up the diagram. Okay, so here's our diagram. Let triangle ABC, this is ABC, with AB equals AC be inscribed in a circle. That circle is called omega. Let D be the point on ray BC such that CD equals 6. CD equals 6. And oh yeah, BC equals 14. So yeah. And let the intersection of AD and omega be E. And we have that AE equals 7. And so one important thing to do here is, actually, I'll hold off on doing this for now. It's a bit more motivated afterwards. Okay, so we're given DC, we're given CB, we're given EA. The problem is very clearly trying to get us to find the value of this because of power of a point. What's the power? So the power of a point, the power of D. So power of a point. Power of D along this line is DC times DB, which will equal 6 times 20, which is 120. And if we let DE equal X, the power of D along this line is DE times DA. And X equals 8 will be our solution. It's very guessable, 8, because like I just like checked a couple of pairs of prime factors of 120, and 8 and 15 differ by 7. So we now know that in fact, this has side length 8. And look at that, we also now have AD, which is quite nice. So now we have to find AC. How do we find AC? Well, let's notice that AB is off to the side, and there's not really a nice way to use AB here. We're like not going to be able to use it effectively, at least. Actually, theoretically, you could. There's a lot of law of cosines bash ways to do this. For example, like if you let this be theta, then you can say that 6 squared plus 15 squared minus 2 times 6 times 15 cosine theta equals AC squared. And then 20 squared plus 15 squared minus 2 times 20 times 15 cosine theta equals AB squared. And then you can solve for theta. And note that like I'm doing law of cosines on like that one and that one, but I don't like that solution. It's very doable. There is nothing wrong with using that solution. And I'm pretty sure it would actually give you a still pretty quick solution. I think a more slick way to do it though is put them off in a box. I'll think about it. I may go back and just like write it out just to see how quick the computation is. A nice way to do it is to drop this. And a nice property of isosceles triangles is that AM is actually also the altitude. And whoa, look at that. We know MD equals 7. We know that AD equals 7 plus 8 equals 15. MD does not equal 7. MD equals 7 plus 6, which equals 13. So by Pythagorean theorem, AM equals square root of 15 squared minus 13 squared, which equals square root of 56. And now we can find the AC squared. Now we just finished by saying AC squared equals AM squared plus MC squared, which equals 56. Huh. Yes, and then since E equals MC squared, this is 56 plus E. It's kind of random that appeared. So yeah, MC squared equals 7 squared. So this is 56 plus 49, which equals 105. I'm actually kind of curious now what the law of cosines solution, if it works. Okay, so firstly, law of cosine on triangle ACD. So this becomes 15 squared plus 6 squared minus 2 times 6 times 15. Cosine of theta equals AC squared. Law of cosines on triangle ADB. That becomes 15 squared plus 20 squared minus 2 times 15 times 20 cosine theta equals AB squared. Since AB equals AC, this becomes 15 squared plus 6 squared minus 2. This is quite fascinating. Okay, and then yeah, as then in that factors, this thing can equal 20 minus 6 times 20 plus 6. So then cosine theta equals 26 over 30, at which point you plug that back into here. So AC squared equals 15 squared plus 6 squared minus 2 times 6 times 15 times 26 over 30, which equals minus 6 times 26. And I've got to assume, and yeah, that equals like 225 minus 120, 105. Yay, that also works. Okay, I did not expect that. That was actually really and very quite nice calculation. Rather surprised. It was not necessary tangent though. Okay.